SOLID is an acronym for 5 design principles that are intended to make object-oriented design more flexible and maintainable, or at least that's what Wikipedia says. But as usual, I'm going to demystify each individual principle for you using examples in the Go programming language. So without further ado, let's get started, starting with the single responsibility principle. The most important two things to understand about the single responsibility principle are these. One is that this principle is about people, and two is that people are almost guaranteed to request changes. So what makes this principle a bit difficult to understand for engineers is that we're kind of merging the understanding of people, more specifically the way a company organizes people, with the way that our code is organized. So in this principle, we're kind of bringing together the non-technical, that is, a company and its many departments and the specific business needs of those departments, with the technical, which is the way we structure our code. And this is a bit of a switch from the principles and design patterns that focus purely on the technical aspects of things. With the single responsibility principle, what we want to do is we want to make our code modular in that each module of our code is responsible for a single narrowly defined business function. And where does that narrowly defined business function come from? It comes from a person or group of people that are likely organized into a team or department within a company. So let's bring this all together with an example. Let's say we have a fintech company and this company has multiple departments. And this company's software uses a microservices architecture which is comprised of multiple internal services, the main one being the payment service. Now in this example, since we're dealing with microservices, we'll say that each service is a module. But you should note that the definition of a module is going to change depending on the scope of our focus. So if we change the scope of our focus to an individual service as opposed to the overall architecture, a module might be a class within that service. But for now, module equals service. And let's say that the accounting department needs accounting reports generated based on payment data persisted to a database by the payment service. Now, the naive way of approaching this would be to add this accounting report generation business function to the payment service. But the problem is this: the payment service already has its single responsibility, aka its business function, and that is to handle the customer payments. And we don't want to tightly couple the payment functionality with the report generation functionality. And one example of a negative side effect of doing that is this. Let's say that the accounting department wants us to update the format of the reports that get generated, because remember, people are almost guaranteed to request changes, as I mentioned in the beginning of this explanation. And let's say that the engineer that goes and makes this change writes a bug into the code that somehow makes it to production, and that bug causes the entire payment service to be unstable. Now, the payment service needs to deal with hundreds or even thousands of customer payment requests per second. So as you can imagine, the impact of this service being unstable would be quite substantial to the business, not to mention the cause of this instability has absolutely nothing to do with the payment service's actual responsibility, which is to handle customer payments. This means that changes requested by the accounting department impacted completely different departments. Now compare that to the alternative approach where the report generation business need is separated into its own service. Now, if something goes wrong with the report generation service, it's completely isolated from the payment service. Instability on the report generation service would have no impact on the stability of the payment service because they are completely separate. So the accounting department's requests to make changes are isolated to the module that handles the accounting department's business needs. That is, the single responsibility of the report generation service is to generate reports for the accounting department. That means that now any requests to make changes by the accounting department won't impact other teams if we're following the single responsibility principle. So that's the single responsibility principle applied to an entire distributed system. But this principle also applies on a more granular level, including within an individual service. So let's just zoom in on our report generation service and see how this principle applies within the individual service. So here we have our report generation service. And this service is a simple API with one endpoint, which is used to generate a report using the parameters bank ID and report type. And there will be two report types that we'll be able to generate a report for, but we'll get to that in a second. So this code is going to be available in the description, and this code is the code where we're not making use of the single responsibility principle. So what we're going to do is we're going to go over this code and what it's doing, and then we're going to see where we can improve the code to make use of the single responsibility principle. So you can follow along by getting the code in the description below. So like I said, this is the report generation service, and it's just a simple API with one endpoint that the accounting team can call to generate a report of a given type. And the first thing that we're doing here is we're just instantiating the database. So we're just connecting to the database here, and we're assigning it to this DB variable. And this line here is just going to make sure we close the database connection if the function closes or the function ends. And what we're doing is we're creating a report factory. And the report factory is going to have a factory method that's going to instantiate the report or create reports. And I'm going to go into what I mean by that in a second, but first let's just go over the top level overview of what this API is doing. So when the client hits this V1 report endpoint, we're going to extract the bank ID and report type from the query parameters, and then we're going to make sure both of those query parameters exist. If they don't, we're going to return a bad request status. And that's just going to be a 400. As you can see here, 400 is bad request. But if the bank ID and the report type do exist in the query parameters, we're going to convert the bank ID to an integer. And then here is where we're going to use the report factory to create the report. And as you can see, this create method, the report factory's create method here is going to take in a bank ID and a report type. And once the report is created, we're going to save the report. And this is so that if this same report needs to be generated again, we don't need to go and generate it. We can just return the persisted report that we saved last time we created it. And once we save the report, we're then going to send the report to the accounting team. And here is just where we start the server and we listen on port 8080. So that's the top level overview of what this report generation service is going to do. So now let's go into the actual details of the code. So the first thing to notice is we're using the factory method pattern so that we can actually create the reports. And if you're not familiar with this pattern, just know that the factory is going to be the thing that creates the report objects. So in a regular factory, in like a real world scenario, maybe a car factory is going to create car objects. This report factory is going to create report objects, and this will become more clear to you in a bit. And this construct is essentially just the constructor method for this report factory. So if we go ahead and go to the definition of construct here, it'll take us to where this report factory is defined. And in Go, we don't have classes, but we can kind of emulate the behavior of classes by creating types. So this report factory type can act as a report factory class. And DB here is essentially a class field. So if you're more comfortable thinking about things in an object-oriented way, that's fine too, because we're pretty much doing the same thing we would do if we were creating a class. So we're creating this report factory type, and then we're creating this constructor method for this report factory type. And what this method is going to do is it's going to construct a report factory. So here we're returning essentially an instance of report factory, and this construct method gets the DB injected into it. And then we're passing that to the DB field when we're actually creating this instance of report factory. So that's basically what we're doing here. When we're doing report factory.construct, we're injecting the database into the report factory, and we're left with this report factory here. Now let's go back inside of the report factory. So when thinking in terms of the single responsibility principle, this report factory, or this report factory class, if you want to call it, is going to be our module. This is one of the modules that we're thinking about. And if you remember when I was talking about applying the single responsibility principle to the overall microservices architecture, in that context, a module was an actual service. Well, in this more granular context where we're actually inspecting the service's code, and for the purposes of this explanation, the module is going to be the report factory in this case. And this report factory has the responsibility of creating the reports. Now, there's one thing that you need to keep in mind when we're talking about the single responsibility principle, and that is that a module should be responsible to one and only one actor. And when I say actor, I'm talking about an actor within a company structure like I mentioned before. So in this particular case, this report factory is responsible for creating the reports, right? So the actor in this scenario is the accounting department. The accounting department is the department that requests these reports and specifies the types of reports that need to be generated and sent to them. So we can say that this report factory is responsible to the accounting department. So that means that this module should only have one reason to change. And what I mean by reason is this module should only need to be changed if there is some request coming from the accounting department, because this module is responsible to one and only one actor, which is the accounting department. So for example, right now, this module, if we go down to this create method here, it takes in a bank ID and a report type. And right now, this create method can generate or create two different types of reports. It can create a payment report, and it can also create a debit report. And the debit report basically takes the debit transactions from a debit transaction table, and the payment report takes the payment transactions from a payment transactions table. But if the accounting team at some point needs us to be able to generate a report for something different, say for example, maybe they would need another report for like refunds. In that case, that would be a perfectly logical reason for this module to need to be changed. So far so good, right? Well, there's an issue here with the responsibilities that we're assigning to this report factory module here, and that is this part here. So here we're actually querying the database. So we have all of this database logic here. So if the report type's payment, we're going to create this prepared statement, and then we're going to use it to query the database. And then we're taking the results from the query and assigning them to this variable here. And then we're returning the report. And you might think that that's fine, but it's actually not, because if there needs to be some changes to the way that we actually obtain the data that's necessary for the report, we'd need to come and make the changes to this module. Now, if you imagine, the accounting team would never request that we make changes to the way that we're actually aggregating the data for the report. That's going to be something that either the engineering team or like the DBA or like DB, the guys that manage the database stuff are going to be more focused on. For example, let's imagine that this query that we have is really poorly performant. Like say we have like a very slow query here. In that case, the engineers would probably come together and decide on like revising the query or coming up with some other solution to actually obtain the data that we need to return the report to the accounting team. But the accounting team doesn't care about those underlying implementation details. And this module shouldn't either, because now this module has two reasons to change. It has the reason that I just mentioned, where we might want to revise the way that we actually obtain the data for the report. And it also has the correct responsibility for this module, which is if the accounting team wants to add an additional report type to this module. So at this point, this report factory module goes against the single responsibility principle. So what we would need to do to rectify this is we would need to abstract this DB logic to its own module. And then that would mean that this report factory would be responsible for one thing, and that would be to create the actual report object via this factory method here. So let's go ahead and see what we can do about that. Okay, so although it might not be the best way to handle this, a quick and easy way to handle this is to just create another class and another package. So we can go to our internal folder and we can just create another package and we'll just call it database. And within that folder, we'll just create database.go. And we can just go ahead and copy everything from here and we can go and put it inside of our newly created database file. And of course, we'll change the package name to database and we'll change this to database as well. And we won't need that. And we'll return a new database when we construct this database. And this will also be a database. And let me just get rid of that. And here, we'll just change this to payment amount sum. And for the parameters, it's still going to need to take the bank ID, but we're not going to take the report type here. We're actually going to take DB, which is going to be a pointer to SQL.db, which is the database connection instance. And we're going to return a float 64. And for this payment amount sum, we'll just do the payment aggregation stuff. And then we'll create another one for debit amount sum as well. So let's just do this payment one first. So we're not going to need that. And we're not going to need any of that. And what we're going to want to return here is the total in here, or the sum of amount that is returned from the aggregation here. So most of this is going to remain the same. We're still going to create a prepared statement here, but we don't need this RF anymore. So we'll just do db.prepare. And this we can move in. And since we're returning a float 64, we can't return nil here. So it has to be 0. And once we execute the query and we get the total, we can just go ahead and return total and nil. So now if we go back into our report factory, instead of handling all of this database logic here for the payment report, we can remove it. And now we can create an instance of that database. And of course, we're going to need to import that. So that's the package that we created. And now we're constructing it here and it's just returning this instance, right? So we can go back here. So if report type is payment, and actually we can put this before the if statement because both conditions are going to use this database instance. So if report type is payment, we're going to do total equals database.payment amount sum. And we need to pass in the bank ID and the DB. And actually we need to make sure we catch the error as well. And if error is not nil, we're just going to return error. Actually nil and error because there won't be a report at that point. And now when we return this report here, we're just going to add that total to the report that we're instantiating here. But now, as you can see, if we need to make changes to this payment amount sum to the way that we actually retrieve the data, it's not going to impact this report factory. And if we make changes to this report factory, it's not going to have any relation to changes that may or may not be made in this database package. So let's go ahead and do the exact same thing for the debit one. So we can just use this as a shortcut to get back in there. And I'll just paste this here for now. And I'm just going to copy this one. And now I'm just going to change it to debit amount sum. And this part I'm going to delete. And I'll just take it from up here. And we'll add that there. And once again, we need to change this nil to 0. And we need to remove this RF. And let's format that. So now here we have the debit amount sum, which aggregates the amounts in the debit transactions table, and it does the same thing. It returns the total. So we can save that, and we can go back into the factory. And for this debit else statement, we can remove all of this up until the return, and we can do total error equals database debit amount sum, and we're passing in again the bank ID and rf.db. And actually we don't need to redeclare that, and we need to check if error not equal nil, return nil and error. And actually I was wrong, I do need that. So now here, once again, we're getting the total and then we're returning it in here. And just so it's easier to see, let me just put a space there. So if the report type being requested is debit, we're going to call this debit amount sum. And the same thing, if it's payment, we'll call this payment amount sum. And if the report type is something that's not payment or debit, we'll just have this error unsupported report type. So now this report factory module has one responsibility, and that is to create the report. So create the instance of the report. So it gets the information that it needs to create the instance, but there is no DB logic in here anymore. So now this report factory module has one responsibility, or it has a single responsibility, and it's responsible to the accounting department and their desires to either add or remove report types, maybe even if they wanted to add or change the structure of a given report. This module is responsible to one actor, and that is the accounting department. So now that that part's finished, let's go back to the top level overview of the API. So we've gone over the report factory and its responsibility, and we went over an example of how we can improve it to make use of the single responsibility principle. And this report factory is being used here where we're actually creating the report. The create method, or the factory method, is going to take in a bank ID and report type, and it's going to return the corresponding report. So the report is what's returned from the create method of the report factory. And the report also needs to be saved, and it also needs to be sent to the accounting team. So if we go to the report's save report method, we can get a glimpse of the functionality of the methods to save and send the report. So this is another module. We're talking in terms of the single responsibility principle. This is another module. So this is the report module. Now this module, just like the report factory module, needs to conform to the single responsibility principle. But as you've probably already noticed, it doesn't conform to the single responsibility principle. As you can see here, we have this save report method, and this method once again has DB logic in it. And this DB logic, just like the other DB logic, can actually just be added to this database package here. Because what this is doing is it's inserting the actual report into a accounting reports table. But again, if the engineers or DBAs wanted to make changes to the way that we're persisting the reports, maybe we don't want to save the reports to an SQL database. Maybe we want to generate a CSV and store it on Amazon S3 or something like that. For any number of reasons, we might want to change the way that we're saving or persisting these reports. But this report structure is a requirement of the accounting department. So this report module is essentially responsible to the accounting department as well. Because if the accounting department wanted to change the structure of the report, like maybe they want to add additional fields, or they want to change the field to aggregate some other value, or anything is possible. In that case, we would need to come in and change this report module. And then if the DBA or the engineering team wants to change the way that we're persisting these reports, we'd still need to come into this same module and make changes. So once again, this isn't following the single responsibility principle. And it gets worse. If we go down to send report is also associated with the accounting department, but the sending of the report doesn't necessarily have any relation to the structure of the report here in this module. So let's say, for example, the accounting department wanted us to, like currently, if you look at this code here, we're sending the report via email. But maybe the accounting department requests that we send the report in a different way. Maybe they want us to send it via Slack. Or maybe they want us to send it to some API that maybe they have some developers that developed an API that we can send the reports to. At that point, we would need to come and change the way that the report is being sent inside of this report module. So at this point, there's kind of So at this point, there are multiple reasons for this report module to change. And those reasons come from different actors. So this is violating the single responsibility principle. So the easiest change that we can make is we can just go ahead and take the logic out of this. We can just take this whole save report method here, and we can go into the database package, and we can just create that method here. And we'll just do database. And this time we'll need to take in bank ID, report type, and total. And lastly, database. And we'll need to go and change these to bank ID, and this one to report type, and this one to total. And then we can go back to our report, and we can just delete this altogether. We'll remove it from there, and we'll go back to our main function, and we can change this to database. And actually we need to set database equal to an instance of database. And we'll pass in the report dot bank ID, report dot report type, and report dot total. And can't forget the DB. So now we're calling save report that's from this database package, and the actual report or the report module, it doesn't have that method that has no relation to what this report module's responsibility is. Now, lastly, we would need to abstract this send report to a different location as well. But at this point, based on all of the examples that I've already showed you, you should be able to do this send report portion on your own. And I think that would be a good exercise to solidify your understanding of the single responsibility principle. And you don't need to strictly adhere to the examples that I gave either. There are better ways to do what I just did in the examples. My focus for this video was to help you to understand the single responsibility principle. So I didn't want to convolute what I was trying to teach by adding in more complex implementations of design patterns and stuff like that. But anyways, that's going to be it for this video. In the next video, we're going to be talking about the open-closed principle, so stay tuned for that. And yeah, if you found this video helpful, go ahead and help me out by leaving a like. And if you're interested in content like this and you're not already subscribed, please subscribe. And yeah, I'll see you in the next one.